Hello folks, welcome back to another tutorial. This time I'm going to talk about reverbs, and the reverb of my choice will be a revelation. The approach I'd like to take in this tutorial is not to twiddle the knobs and to see what's coming out of the speakers, but I would like to make a systematic approach to algorithmic reverbs in general. And the idea I'd like to impart is that instead of playing with the knobs, we imagine how the room should sound. Then we tweak the knobs, knowing what we do, and then we will hear what we achieved. And in order to realize this approach, we first need to understand what the knobs are actually doing. So this is my approach for today, and that means that we, including myself, need to learn how an algorithmic reverb operates. For the purpose of learning, I'm going to switch off revelation now, and I will choose a reverb which helps learning. And this will be, in this case, the UAD Dreamverb. I choose this reverb because it boosted my learning of algorithmic reverbs. So before we actually start listening to the reverb, I'd like to make a short walkthrough through the elements, which in my opinion are laid out very well in the Dreamverb. So what is a reverb actually doing? It's simulating the response of a room. And in algorithmic reverbs, the response of a room is divided in two parts. It's the so-called reflections, which are caused by the shape of the room. These are the reflections which happen in the early time of the room response, and these reflections characterize the shape of the room. After the reflections decay, the more diffuse and statistic reverberation takes place. In this case, all these small delays, which you can see here, are put together in a, I would say, mosh of many reverbs, and the character of the late reverberation is more like a noise, and the characteristics of the early reflections is more like a delay or echo. So there are also more elements. I think these elements are clear. It's the input and the output volume. Then you've got a mix button where you can adjust the dry part and the wet part of the signal. And this is very interesting. This is the part where you can actually model these properties of the room you want to simulate. And this is the part where, in my opinion, the Dreamverb is great, because the properties of the room are actually visualized. So let's take a look at the room. And what we can see here, it's an triangular shape of the room, and you can also sweep between two rooms, which is an A-frame, which is this one, and a corridor, which is this one. And while I move the fader, where I can blend these two rooms, just watch the early reflections. And as you can see, the shape of the room influences these very short delays which make up the early reflections. So let's stay with the A-frame. And so this is what shapes these early reflections. There is another component. It's the absorption characteristics of the room, and it's modeled in Dreamverb by using two materials which you can also blend, and in this case I chose hardwood and drapes because the reflection and absorption properties of hardwood and drapes are quite different, and we will also listen to this. There is also a third component. It's the air in the room, which mainly influences the dampening of the signal. So if you, for example, take a smoky club or thick fog, then the dampening is much stronger compared if you take an ideal gas or just dry air. And just like in the shape faders, you can fade and blend between these properties. So right, before we start, let's just listen to the whole reverb, and then I will go through the different elements, including this resonance part, which is actually an equalizer which is applied after the signal is generated. So I chose a drum pattern because drums are always the worst case for reverbs, and drums help us also to actually hear the properties of a reverb. So this is the wet signal, this is the dry signal, and for the sake of this tutorial I will drive the wet part quite high, because this enables us to hear the properties very well. Okay, now let's switch off the reverberation and the equalizer, and now we want just listen to the so-called early reflections. So this is the way an A-frame shaped room would sound without the late reverberation. We can also adjust the size of the room. Now let's listen how the size of the room influences the signal. Small size, even smaller. You can hear that these very dense early reflections actually influence the sound in a very drastic way. It's because short reverbs cause comb filtering effects. So in a certain way, these early reflections influence the signal like an equalizer. Now I maxed out the size of the room, and as you can hear, the dense delays get separated, and you can hear the separated delays. And as I reduce the size of the room, the separate delays again condense into a consistent room response. Now the impression of separate delays has gone, and we can only hear the room. Right? Now let's listen to the way how the room shapes influences the room response. And for this purpose I will fade between these different rooms. So this is the corridor. And now I will slowly fade into the A-frame. And as you can hear, not only the feeling of the room changes, also the sound of the signal changes like a very weird equalizer. Now let's have a look at the absorption features of the room, which is modeled by the materials in the Dreamverb. And let's fade between the hardwood part and the drape part. And let's listen how the influence is. First the hardwood, where we would expect a very low dampening and absorption and a very clear signal with lots of high frequencies. And now if we put drapes over the wood, we would expect a more soft signal, which is much darker. Which is actually the case, as you can hear. We can also enhance this effect. This is here in the filtering fader. So if we max it out, then the absorption properties of the room now have a stronger influence on the reflections. What is happening in a technical way is actually that these delays are low pass filtered in the delay path, in the feedback path I mean. So let's have a listen. Drapes. Now hardwood. Now let's increase the influence of the air. I couldn't hear it. Let's take thick fog. Alright, this obviously has nearly no influence, but I think we will later look at the reverberation, where the influence of the air gets much stronger. Right, I think now it's time to switch on the actual reverberation. Now let's again play with the room properties. I'm going to fade between hardwood and drapes again. This is hardwood. This is drapes. As you can hear, the effect of the material properties now becomes much more prominent. And this is also explainable because the late reflections, the reverberations, model the reflections which have crossed the room many times. So the more a signal is thrown back by the room, the more often it has to go to the material. So a delay which has gone through the material X times will suffer much more absorption than the early delays, which are only reflected by the room once or twice. Now let's have a listen to the effect of the air, and we will see this effect is getting much stronger than in the earlier reflections. So this is nearly only air. Now let's listen to the differences between dry air and, let's say, thick fog. I would say the effect is quite prominent. All right. Now what could we hear? The stronger the signal is absorbed by the material, the more prominent the loss of the highs gets. So the more often delays have to go through the material, the more highs you lose and the darker your signal gets. Now to conclude this, I will also play with the room shape. And this time I switch off the reflections. And let's hear if the shape of the room influences the late reverberation. And as you can see and hear, there is no influence on the late reverberation. And if you play with these parameters, you can also see that this shape doesn't change in any way. So this is caused by the way these plugin or this reverb is modeled. Actually, in nature, the room shape, of course, will also influence the late reverberations, but because the late reverberations have a more statistical nature and are much more strongly influenced by the inherent material properties of the room. Also in nature, the actual shape of the room doesn't much influence the sound of the late reverberation. Of course, the room size will influence it, and we can also hear this. So if you increase the size, right. So this is what we would expect. Another very important parameter is this diffusion here. In this parameter you adjust the, I would say, randomness of the reverberation. So if I put down the diffusion, then you can see that the late reverberation delays, single delays, become more prominent. And if you increase the diffusion, the delays become much more random. Let's listen to this. Low diffusion. So if you listen carefully, you might notice these single delays. And if I crank up the diffusion, you will not be able to hear any single delays. It will be just a mush of reverberation noise. Alright, so that's the way how an algorithmic reverb works in the basics. Let's have a look at the very last element. It's the resonance, which is actually an equalizer, and as you might expect, if I change the gains of the bands, then you can influence the sound of the reverb. So for example, if I put down the lows, then the low droning reverb will decrease. Like this. And I can also damp the highs. So that's what you would expect of an equalizer, nothing special and nothing fancy. Right. Now let's listen to the whole show. a short drum room, large hall, right. I think in Dreamverb you can model rooms and halls in a very intuitive way. Now let's have a look at the very last, in my opinion, interesting parameter is the distance. Actually, the distance influences all parameters in order to simulate the distance of the sound source. So in this case, the drums, if you set the distance to 0, the fronts are directly in front of you and you are surrounded by the room, and the more you increase the distance, the more far away the drums get. So if you imagine, for example, this room, if we are standing here, then the drums are just directly in front of us, and the more I increase the distance parameter, the more the drums will wander until they are standing against the back wall. Okay, now let's listen how they modeled this effect, and let's analyze what's actually happening. For this purpose I set the distance to 0, and let's listen. And now I let wander the drum set back into the room. And back again. So now what's actually happening? I think the first thing you will hear is that the more you increase the distance, the more the drums disappear in the reverb. It's just like playing with a mix button. So if you take dry, you've got the direct drums without any room. So now the drums completely disappear into the Hawley response of the room. If we listen again, we can also hear another effect. Let's increase the drapes in order to increase this effect. So the reverb signal is getting much darker, and this simulates in a way reverbs are influenced by the actual physics. So if the drums are far away, the reverbs take a long time and also take many reflections by the wall, and if they arrive at the listener, which is me and you, then lots of the highs are already absorbed by the material, which is in this case drapes. So this explains why the drums, if they are far away, sound much darker than the drums which are standing just in front of you. Let's listen to this effect again. So I'm pulling the drums towards us, and you will hear that the highs will get much stronger. Right, I think we can conclude this, and I hope you and me got a basic understanding how an algorithmic reverb works and how it is trying to model the very complex nature of reverbs. Okay, now let's switch to our actual candidate, which is in this case the revelation reverb, which I wanted to explain in this tutorial. First, let's listen how revelation actually sounds. Great sound, I would say. Okay, the experiment I would like to make now is we first imagine the room, then we turn the knobs, and then we will listen how our setting actually reflects the room we imagined. Okay, where could we start? I'm switching to A. I would say we start with a drum set which is standing close by. So we are standing in front of the drums. I would choose a medium room with, let's say, wooden walls, maybe some drapes, a carpet on the floor, and the room should have the size of, let's say, 10 meters. And if it's a crater, let's say it's 10 meters deep and 10 meters wide, and let's say 3 meters high. Okay, now the question is, how can we achieve this? First, I suggest that we go through the different elements and we try, and I try, to understand what these elements are actually modeling. So let's start, I would say, here. So these elements model the algorithm, just like in the Dreamverb. Opening it again. So in Dreamverb you've got the reflections, and this is modeled here. And you've got the reverberation, which is modeled here, and it's called tail because it's the so-called reverb tail. Right. Okay, early reflection. What can we influence? It's the size of the room. I would say let's, for demonstration purposes, switch off the tail. We can do this with this fader. So if we push up the fader, we got 100% early reflections, and if we put it down, sorry, it's just the other way around. If we put it down, we get the early reflections. If we shove it up, we get only the tail, and if we choose a value in between, we get a mixture of both. Right, so this is going to be very short, and this small thing you can see, it's only the early reflections. So if we change the size, you can see how the reflection pattern increases and how the single delays get separated. Just like in Dreamverb, if you change the size of the room like this or like this. Alright, so let's take a medium size. I hope this is modeling my 10-meter room in an adequate way, and let's have a look at these parameters. It's low cut and high cut, and I would say these two parameters model the room absorption properties, just like the materials in the Dreamverb. So, for example, if we have got the drapes, then I would turn down the high cut in order to model the absorption of this soft material. And if we switch to the hardwood, I would crank up the highs, and maybe I would also high pass the lows in order to model the very high-ended reflection pattern of the hardwood. So if we say we've got a woody room, I will crank it up, but because we have got a carpet on the floor, I put down the highs a bit, just let's say like this. Okay, how is this actually sounding? Let us see. Maybe I crank up the size a bit. Just as a comparison, I'm going to switch off the reverb without. Now with the room. I think it helps if we crank up the insert a bit. Bit too strong. Without, and now with the early reflections. Okay, right. I think this sounds convincing. Now let's have a look at the tail, or the actual reverberation. For this purpose, I'm moving the knob to the tail part. And now there's another parameter, pre-delay. So this is interesting. Just imagine we are standing right before our drums. So the very first signal we will hear is just the drums only. And then after a short delay, the room response will appear. So if you are close to the drums, we should put up a small pre-delay. And this simulates the effect of firstly hearing the dry signal and then later hearing the room response, which is delayed because the room response is created by the room and it takes some time to put up the reflections. Right. Now let's have a look at the tail parameters. So what is this delay actually doing? Okay. All right, we have to be careful. There are two delays. This is a general delay, which delays the whole reverb. And this is only the delay of the tail. So in my opinion, I just want to delay the actual tail and just put up a very small amount of pre-delay, because the room is not very big, and so the early refractions will only take a very, very short time for arriving at our ears. And the tail will take a bit longer. Right, so room size again. This room size parameter is like this parameter. So the more we crank this up, the longer the tail will be. If I put it down, you can see what's going on. I think it's obvious. So I'm taking a value in between. So this main time, what might this be? Okay. It looks just like an elongation of the very late tail. So I think both parameters kind of model the size of the room. Maybe this is the overall size of the room and this is the length or the depth, I should say, of the room. Right. Now there's the room shape. This is funny because the room shape actually mostly influences the early reflections, and it does not influence the late reverberation. But anyway, they choose at Steinberg to put this parameter into the tail, and now let's see what's changing here. Well, it's not explained, so I think we should just trust our ears. There's the density parameter, which corresponds to the diffusion parameter. Again, if we put down the density, the signal kind of falls apart into single delays, as you also can see here, and if we crank it up, then it will become a whole wash of delay. And as the room absorption properties influence the late reverberation, you can also adjust just the high cut of the late reverberation. And because we chose a room with carpets, I will put it down a bit. So a width is actually the stereo width. I put it to 100% because I want a wide room. Right. But we are not actually done. There is another interesting control here. And I think you can compare it in a way with this parameter, but there is a main difference. As much as I know, this resonance parameter actually is an equalizer behind the reverberation unit. And this parameter is influencing the delay path. So let's go through the parameters. You've got a low frequency and a high frequency button. It's like a kind of shelving filter which is overlaid over the signal. So if I'm shifting up the low frequencies, then you get an low shelf cut over the signal, which will look like this. And you can also see it truncates the length of the delay because the high frequencies are going to disappear. Right? So now for the high frequencies, it's a kind of high shelf. So if you move the high frequencies, you influence the highs of the signal, and then you've got these two parameters, high and low time. So what's actually happening here, in my opinion, I'm not 100% sure, but we will have a listen. If we say set this value to about 300 Hertz, if low time is set to 0%, then this parameter will actually have no influence. So if we lower the low time, then all frequencies below 300 Hertz will be dampened. So all low frequency will disappear faster than the high frequencies. If I crank it up, then the decay of the low frequencies will be longer. And if I crank it down, then the decays of the low frequencies below 300 Hertz will be shorter. And it's the same with high frequencies. So let's put it to about 5 kilohertz. If I set it to 0, then this parameter has no influences. You can see it also in the graphical display, right? Nothing going on here. And if I crank it up, then the decay of the high frequencies above 5000 Hertz will be elongated. And if I put it down, the decay of the frequencies above 5 kHz will be shortened, as you can see. So this is the shortest, so the reverb will sound soft and muffled. And if I crank it up, the reverb will sound bright and maybe even metallic, even like a plate. So, but we don't want to model a plate, we want to model a real room. And because we have carpets on the floor, I would say, well, let's just keep it here. And the highs will be muffled a bit. And the lows, I would say, are quite prominent and are elongated a bit, I would suggest. Right, so I think we covered all parameters now. Now we take a mixture between the early reflections and the tail, and because we are directly standing in front of the drums, I would say we dial in a properly portion of the early reflections. Okay, the last section is the modulation parameter. This modulation is actually not happening in real rooms. It just modulates maybe the delay or some parameters of the internal delay path, I don't know. So it's something artificial. It of course has it has artistic purposes, but in this case we want to model a realistic room, so we switch it off. Okay, now it's the moment of truth. Let's listen if we actually modeled a room with a size 10 by 10 and height of 3 meters in order to validate if our imagination corresponds to the actual parameters. Now let's listen how good we took our choice of parameters. Okay, in my opinion the drums are still too far away, so I'm cranking this down. Alright, I think, in my opinion, we quite got it. Now let's play a bit with the early reflection in the tail, and what should happen if I crank this up, and then the drums should move away from us. Let's listen if this effect takes place. Great, it seems to be the case. Now let's see if we crank this up, the signal should also become darker, like if we played with this parameter. We could also adjust this just by turning down, for example, the high cut of the tail, and maybe turning down the high time decay parameter. Right, that went quite well, I would say. Okay, now let's A/B these two settings. So we are standing right in front of the drums. We crank up the high parameters. So this is the setting for the closed drums. Oh, wait a minute. I copy the A setting to the B setting. So this is our B setting where we crank up the tail, turn down the high decay, turn down the high cut of the tail, and maybe a bit of the early reflections. So now, okay, I also should turn down the pre-delay and also this delay, because if the drums are far away, then there will be not much difference between the direct signal of the drums and the reverb signal. So I turn the pre-delays and also this delay to 0. So what we should have here is now the same room with the drums directly in front of us, and this is the setting with the drums attached at the back wall. So now let's listen if the simulation is convincing. Drums close, drums at the back wall, and drums close again. Yeah, I think we got it. Right. So this was an idea in order to introduce the parameters of the Revelation plugin. There is some other parameter. This is the early reflection model, so you can also switch between halls, chambers in studio. For example, if our room is even smaller and more shaped like a studio, we can change this. Okay. We are nearly at the end now. Just as a conclusion, our experiment was not to play with the parameters and see what's coming out of the speakers. Instead, we used our imagination, and with the understanding of the parameters, we wanted to transfer our imagination of the room and our idea how far we are apart from the sound source. And so we first set up the parameters and then afterwards listened if the simulation worked out properly. In my opinion, this is a much better approach than just playing with the parameters, and I would encourage you to choose this approach. So then we are done. I hope you enjoyed this tutorial, and goodbye.